All right, so welcome back to OneClass. Again, my name is Joey. I'm going to be your math teacher for this session. So what we're going through currently is we're going through a session of verifying verifying solutions on live streams. And what we're doing here today specifically is for the next hour or so, I have about 11 questions for us to verify in kind of grade 8 to grade 9 math. So we have kind of problems in algebra 1, geometry, as well as pre-algebra as well. So we're going to look at these questions, and we're going to look at the solutions to these problems, and I'll walk you through my thinking processes, how to approach a solution, as well as we're going to verify the solution that's given and see if it's correct or incorrect. Just a little bit of myself. Again, my name is Joey. I'm currently a secondary school educator in Ontario. I'm focusing specifically on teaching chemistry and as well as math and music down the road. So that's going to be my kind of goal there. And yeah, if you're tuning in for the first time, thank you so much for watching. Feel free to again wave hi or ask any questions during the stream on the stream chat, and I'll hopefully be able to, if time permits, answer your question as well. And I'll try to gear towards the questions that you ask as well. So without further ado, let's get started on these problems for today. So we have our first question here. It's asking us, how do you simplify the square root of 72? So let's see here. So simplify square root of 72. Now there's two ways to kind of approach this problem. The first way is to kind of use square root of 72, sorry. You have two ways to think of this problem. You can think of this problem as, right in blue, as kind of approaching it using simplified radical form, where you're kind of taking the prime factors and you're kind of breaking down the 72 to basically an integer or a whole number and its square root. So that's some kind of simplified radical form. It kind of uses this concept of prime factors. And then we simplify using prime factors, or you can think of this question as, I believe the solution is doing. Here is the kind of the method as long division. So you can approach this using long division. And instead of giving you, and this would give you, this would give you actually, your answer here would give you an integer. So basically a whole number plus a radical. So it simplifies the radical into a whole number and radical. And long division, basically long division here, it's a special kind of long division using squares. And it would give you, this would give you a approximate decimal value. So there's two ways to go about this question, and it doesn't really specify which one to go over. So let me do the first one, because then they haven't actually they didn't really do the first one in the solution here. They only did the long division method here. So let me do number one here. Let me show you what simplified radical form means. So this is a simplified radical form using prime factors, and our answer here should be integer plus a radical, or even just an integer. Let me include that, or just an integer. So let's use simplified radical form, and then I'll walk over the solution for long division here. So in simplified radical form, I would have to write our problem here, which is square root of 72, right? So we have square root of 72. It's asking simplifying the square root of 72. So here, this is the square root of 72. And what we're gonna do is we're gonna take some prime factors. So when we talk about prime factors, we are trying to break this number down, 72, into its kind of basic blocks. So I look at 72 here, and I know it's an even number, so I know it's divisible by 2, right? So I can say that I can divide this 72 by root 2, or dividing 72 by root 2 here, and then I'm going to basically multiply it by whatever 72 divided by 2 is. So I'm kind of working backwards here. Now 72 divided by 2 is indeed 36, so I would have the square root of 36, like so. And what we could do now is we can actually finish the problem here. And this solution is done because we actually know the square root of 36 here. We know the square root of 36 here is 6, right? And how do we know that? Well, we know that because we know that 6 squared here equals 36. So therefore, the square root of 36 would equal 6, right? Again, the square root and the square cancel out here, right? So you would get the square root of 36 equals 6. So we know that 6 times 6 equals 36. So therefore, our answer here is root 2 times 6. Or if I were to rewrite this, I would say, I would place the integer first. So I would say 6 root 2. And this here is our exact value, or the simplified radical form of root 72 here. So this here is number 1, and this here would be our simplified radical form. So it depends on how this question is being asked. It's asking us how do you simplify, or how do you refine the decimal here. So this would be the simplified radical form. So let me say, I'll write my answer here. I can say therefore root 72, or 6 root 2, sorry. 6 root 2 is the simplified radical form of root 72. And that here will be our answer here. If we want to do number 2, though, if we want to do the long division here, I'll walk you through the solution here, just for the sake of time here. So you're basically doing a lot, like, don't worry about these, you can read this on your own, but if I were to look at the math here, it's basically doing a long division type of thing. So I have 72 as my dividend and 8 as my divisor. I'm thinking of what number, or sorry, I don't have 8 here. First, I have nothing first. I have basically just the divisor here with 72. I'm thinking of what squared number, which number squared would be closest to 72 without going over. So it's kind of like division, but you're not given our divisor and our quotient immediately. So we have to think of them as squares. So 72 here, the closest squared number would be 8, right? 8 squared here is 64. So they subtracted 72 by 64 here to get 8. And then what they're doing here, once you get 8 here and 8 here, what you're going to do is you're going to double this quotient here. So 8 becomes 16, and this here becomes your new divisor. Now you're going to have 16, and then what you're going to do is you're going to bring down 2 zeros here. You're going to add 2 zeros to 8 to make it 800. And then you have 1, 6, and basically this digit is not found yet. You don't know that this is a 4 yet. And you want to know what number would you put into the into the quotient and the divisor to make the closest number to 800. So you basically try 161 times 1, 162 times 2, 163 times 3, and you know that 164 times 4 here gives you 656, and this would be the closest number to 800 without going over. Now, we have 164 times 4, which gives us 656, and then we subtract 800 by 656 to give you 144. Again, we double our quotient, right? So we double our 4 here to get 8. So our next value here is 168, and then I'm gonna leave this next digit here blank. So I have 168, 8 or 168, and then a blank here, and then again I add 2 zeros into the difference here to get this is 14,400, and I'm thinking of a value to put into here. So it's 1681 times 1, 1682 times 2, and so on and so forth. And the closest value to 14,400 is indeed 1688 times 8, which would give you 13,504 here. And I subtract that to get 896, and you can keep doing this process till you get more decimal places. But 8.48 here is the we kind of basically stop at 2 decimal places. So this solution here is correct, or you could do 6 root 2 here, and this here would give you also, if you did the if you put this into your calculator, this is also approximately 8.48 here. So this solution here is correct. And you can say it's plus or minus if you really want to be really specific here, but this solution here is correct. So 6 root 2, it's either 6 root 2 or this long division solution here. So solution is correct. And then I'll say if placed in simplified radical form, solution is 6, and then I'll say square root 2. And then I'll just write the little work here. I'll show my work here. Equals, this would equal square root 2 times square root 36, which equals 6 square root 2. Okay, so this your solution is correct, indeed correct here. Okay, number 2. How do you write 32 thousandths as a decimal number? Okay, so I'll just write here, write 32 thousandths as a decimal number. So let's look at this problem here again. The goal here is to write 32 thousandths as a number, right? So if you look at this problem here. Sorry. Our numbers here are 32 and we have thousands, right? So with 32 is obviously 32, and thousands, I could rewrite this as 1,000, right? And again, it's 1,000, right? So if I want to write it as in a decimal number, what I would get is I wouldn't get a whole number in the front, right? So I'll have 0 in the front. So it's basically 0 point. And then how many digits do we have? Well, we have 1, 2, and 3, right? And the reason why we know we have 3 digits, or we have 3 digits, is because it's given here. The thousandth here means it signifies 3 digits here. So let me break this down for you. So I have here, this guy here is a tens digit. This guy here is the hundreds or the hundredth, and this here is the thousandths. And if you kept going, the 4th digit would have been, for example, this 4th digit is the 10,000ths. 10,000ths digit, and so on and so forth. So remember, decimal is based on a factor of 10 here. So in this case, we only need up to 1,000, right? So I'm going to erase this 4th one here. And finally, my answer here, well, I have 32 thousandths, right? Well, if I have 32 thousandths, then I simply have to write 32 in these two sections here, because again, I don't have any. You can think of this as, again, tens, hundreds, and thousands, right? So this is 32 thousandths. So because I only have 32 of them, then I would write a 0 here and a 32 here. And the reason why I wouldn't put like just simply 32 here is that if I were to do that, if I were to put just 32 here, this here is not thousands. It's not in the thousands place, right? Or if I put a 0 here, this is not in the thousands place. This here would have meant 320 thousandths and not 32 thousandths. So you need to put the 0 in the first digit here to signify that there's no tens digit. And I would have 3 and 2 here because I have 32 thousandths. So this here is the correct solution. So this here is, therefore this is 0.032. And this here is the correct solution, like so. So the solution here is correct. Good analysis as well. Okay, number 3. So it says convert 5/16 to a decimal. Convert 5/16 to decimal. So again, this is a lot of pre-algebra questions here. So what we have here is we have 5/16, and what we're going to do is we're going to do long division, because right now we currently have what we have here is a fraction, and we want to switch this to a decimal, right? So that's too easy here, sorry. I'll switch this to a decimal here. So fraction to a decimal, so that's okay. So in order for us to do that, we put the denominator, which is this guy here. He's going to become our divisor here, and then our numerator here is going to become our dividend. So this will divide by 5 point, and you basically add some zeros here. These zeros will act as our decimal places here. So 1, 2, 3, put 4 here. So we basically do long division like normal, right? So 16 times what number will be closest to 50? I believe it's 3 that's closest to 50 here. And once I have 3 here, I can basically write a 0 point here, right? Remember, the decimals here have to match up here. So this point and this point here, and I get 60 times 0. I can't have the first digit here. It's not going to go into 5 here. So I can safely assume that this here is 0. 60 times 3 here equals 48. 50 minus 48 here is 2. I bring down a 0. 16 times what number gives me 20? 16 times 1 is closest to 20 here. 20 minus 40 here is 4. Bring down another 0. 16 times what number would give me 40? In this case here, it would be 2, right? 60 times 2 is 32. So it's the closest number here. 6 times 2 is 32. 40 minus 32 here is 8. Finally, I bring down the last 0 here. 16 times what number would give me 80? Well, I know that 16 times 5 here gives me 80, right? Because 5 times 6 here is 30. 5 times 1 here is 5. Plus 3 here is 8. So this here is remainder 0. So therefore, my answer for this problem here is whatever our quotient is, right? So in this case here, this guy is our answer, right? So I can say, therefore, 5 over 16. So that's 5 over as a decimal is 0.3125. And this here is our solution for this problem. And as you can see, this here is also the correct solution as well. They did it in an odder way where they convert a fraction. They need to check the denominator. If the denominator is the power of 2, then divide the fraction up by 2. Divide the fraction by 2 up to the power of 2, as in 16 equals 24. So divide the numerator 4 times. Okay. So what they did was they put 16 here they rewritten this to a power of 2, so it would be 2 to the power of 4, and then what would they do? They would divide 5 by 2 4 times to get that this one here. This solution here, I'm not particularly fond of it just because it doesn't it does get very, very messy when you're dividing decimals by 2 here. Like 0.625 divided by 2 is, how do you know it's 3125? So you basically have to do a long division again. So I would prefer, the solution is correct here, but I would prefer they use long division. They use long division to avoid errors when dividing decimals together. Dividing by decimals. So the solution here is correct, but I didn't really like this analysis in this case here. Okay, number 4. It's asking us, how do you convert 0.35 to a fraction in lowest terms here? So convert 0.35 to fraction in lowest terms. Okay, so again, we're now, instead of going from fraction to decimal, we're going from decimal to fraction, right? As you can see, we have a decimal here, and we want a fraction as our answer, right? So how do we do this problem here? Decimal to a fraction. Well, I'm going to look at my decimal here first. We already analyzed a kind of what a decimal is in the previous question. But as you can see, we have 0.35. Again, my first place here, I know that this is here is my tens digit, and this guy here is my hundredths digit, right? So if I have a number, or if I have any value in my last kind of digits here, this will be my denominator for my fraction. So 0.35 therefore equals whatever. I have a fraction here. A denominator is going to have to be basically the last digit of my decimal here, and in this case here, it would be 5, but then remember 5 is in the hundreds place, right? So in the hundreds place, then therefore this denominator here is 100. So if 100 as my in the last digit here, if it's in the hundreds place, then my numerator is simply just whatever's in the decimal here. So this here is simply just 35. So I have 35 over 100 here would be my fraction, and then what I want to do is I want the lowest terms, right? Remember, therefore I need to reduce my fraction here to lowest terms. So if I have 35 over 100 here, what I could do is I can simply reduce. So I can divide both the numerator and the denominator by a specific number, right? In this case, because they both end in 5 or 0, I know that this is divisible by 5, right? So 35 divided by 5 here would be 7, and then 100 divided by 5 here is 20 here. So this here is my solution, right? So I can say that therefore 0.35 to fraction in lowest terms is 7/20 here. And this here is our solution for this problem here. And as you can see, they did the exact same thing. They did actually an extra step where they actually convert 0.35 into a percentage first, so something over 100, and then they did a percentage into decimal. So either way works, as long as we get to a fraction, just add a percentage to a decimal. And then they basically reduced 35/100 to 7/20 by dividing by 5 for both the numerator and the denominator here. So the solution here is correct. Good analysis. Number 5 says something a fraction. I think it says 0.16 bar here as a fraction. So let me do that for us. So this is number 5. So it says I think the question's cut off here, but I think I want 0.16 bar as a fraction. So there's actually two ways to think about this problem here. There's two ways to think about this problem in the sense that there's one way where it's kind of the memorization way, or the root, or the route kind of way, rote. And I'm going to call this the rote method. Where this is, that kind of looks like an N here. The rote method. And there was another one where you can use algebra. That's what the solution that they did here first. So let me just walk you through the solution, and I'll show you what my memorization method here is. Or maybe more so I'll write down what you would need to kind of memorize for common fractions as decimals here. So it says here let x here equal 0.16, and then you would get and you would multiply this equation by 10 to get kind of our decimal here to be well, you would basically multiply both sides by 100. I don't even have to multiply here by 10 here. So basically you have here. Let me write this down for you. So this is for number 2 here. So this is step 1. Step 2, and I'm going to analyze step 2 first here. So if I have x here equals 0.16, and then if I'm multiplying here by both sides, I would get both sides by 100. I would move this decimal twice here, so I would get 16 point and then 6 bar. Right? Remember, the 6 bar just means that it is repeating here. And then what I would have here is basically I'm making two equations here, right? So I can multiply again. This here x equals 1/6. Sorry. Oops. 1/6, and then I'm multiplying it by 10 by both sides here to get 1.6 here. And basically, what we're doing here is we're subtracting. So we're doing a substitution, right? So we're subtracting equation 1 from equation 2. So we have basically right here. This is 1. This is 2. Subtract 1 from 2 here, or sorry, in this case it would be 2 from 1. So I have 100x minus 10x equals 16.6 bar minus 1.6 bar here. And this here would give me, again, 100 minus 10 here would give me 90x. 16.6 minus 1.6 here would give me simply just 15, and they cancel out here. And then I would simply divide both sides by 90, right? So x equals 15 over 90, which is, therefore, if you reduce this to lowest terms, I can divide both the numerator and the denominator by 5. I would get, I think they both divide by 15, actually. I don't think it's 5 here. If I divide here by 15, divide here by 15, I would get 1/6. And this here is my fraction, right? So therefore, 1/6 here is indeed my fraction for this problem here. So 0.16 bar would equal 1/6. My first kind of method here is the memorization method. So I kind of encourage this method, especially in the younger grades, just because these fractions and decimals are very, very common here. So when say the memorization method, I'm kind of just writing down lists of fractions that you probably need to know. So we know that so we know 1 over 1 here is 1, right? This here, oh, that's 1, sorry. 1 over 1 here is 1. We know that 1 over 2 here is 0.5. Another common fraction is 1 over 3. And 1 over 3 here is 0.3 bar here. And we're just, remember, 0.3 bar just means it's repeating, right? So this is 0.33333, and then basically continues on to infinity here. 1 over 3, and then 1 over 4 would be, we know 1 over 4 is a quarter, right? So we know it's quarters worth 25 cents. And then 1 over 5 here is 1/5, or this would be 0.2. Again, 0.2 times 5 here equals 1, right? And the 1 over 6 here would be the one that I just solved for, so 0.16 bar. And as you can see, there's kind of a relationship to this step, right? I'm going from 1 to half to 1/3 to 1/4 to 1/5 to 1/6, right? So then you see, if you look at the decimals here, they're going down, right? 1, 0.5, 0.3, 0.25, 0.2, 0.21, or 1/6 here. And these are kind of decimals I would highly get you to memorize, just because they're very, very, very common. And with these decimals, they also come the other counterparts, right? So you have 1/3 here. I can also memorize 2/3, 1/4. I can memorize also 3/4. 1/5 has 2/5, 3/5, and 4/5, and then 1/6 also has 5 over 6 as well. And these here are basically, again, fractions you should probably try to memorize, just because they're very, very commonly used here. So if you say solution here is correct, good analysis. Okay, that's number 5. Number 6, how many minutes are in one full week? Okay, so this is a unit analysis problem here. Minutes in one full week. So I'm looking at minutes in one full week. So basically, I'm going from something that's bigger to something that's smaller, right? I'm going from a week to minutes here. So this is, again, a unit analysis question here. So how I would solve this problem, again, I would use the concept of unit analysis or dimensional analysis to help me with my units here. So if I, for example, if I had 1 week in the beginning, I'm starting with 1 week and I'm moving to minutes, right? 1 week here. I'm going to multiply that by how many, again, what's the next kind of conversion here to go to minutes here? I can't go directly from week to minutes, right? We don't know that. But we can go from week to number of days, right? So number of days here would be how many days in a week? Well, we know that there's 7 days in a week, right? So go multiply this by 7 days per week, right? So in this step, I'm converting from week to days first. And so from days, I can convert to hours, right? How many hours in a day? Well, I know there's 24 hours in a day, right? So 24 hours in one day. And as you can see that my units here are canceling, right? The weeks here are canceling, the days are here canceling. And then finally, hours here, how many hours in a minute? Or sorry, how many minutes in an hour? Well, I know that there's 60 minutes in an hour, right? So I can multiply this by 60 minutes per 1 hour, right? And this here will give us our answer, because again, I have minutes here now, right? And my goal here was to find our minutes here, right? So as you can see, here our units cancel out, right? So the weeks cancel out here, right? The days cancel out here. The hours also cancel out, right? This is hours and this is hours here, leaving me with our objective here, which is our minutes, right? This here was our goal, right? So I want 1 week here. So we converted from 1 week to minutes here. So all we have to do is just plug this into our calculator, right? We have 1 times 7 times 24 times 60. And this here will get us our answer, right? So we have 1 times 7 times 24 times 60. Ooh, sorry about that. So 1 times 7 here is 7 times 24 times 60. We have 7 times 24 here. 7 times 24 is, I have 28. 7 times 2 here is 14, plus 2 here is 168 times 60 here. And then finally, I could solve this by simply just doing some work here. Okay, so I have a 0 at the end here, and I have 48 here. 6 times 8 here is 48. 6 times 6 here is 36, plus 4 here is 40. 6 times 1 here is 6, plus 4 here is 10. So I have 1, 0, 0, 8, and then another 0 at the end. And this here would be minutes. So this here is our solution for this problem. So we can say that therefore in 1 full week, there are 10,080 minutes here. So this here is our solution. And as you can see, this solution here is also correct. So they did this, but they didn't really use unit analysis, and they didn't really show me how to cancel these units out. So this solution is correct, but the analysis is not the greatest here. So analysis should have shown how the units cancel out. So the solution is still correct though. So number 6, number 7. I'm looking at how do you simplify the square root of 52. So again, very, very, very similar to the first question of this question set here, right? Where it was asking us, how do we simplify something, right? So again, we can use our two methods. Our first one here was our simplified radical form. Every time we know about this, we actually know the square root, right? The square root gives it away that this here is a radical type of question here. Or number 2 is we want long division, right? So as you can see on the left here, they chose to do the long division solution, so which means I will choose to do the simplified radical solution here. So I'm giving the square root of 52 here, and did I do the square root of 52? I feel like I did. I think no, actually, and that was 72, right? Let me look back here. Yeah, this was 72, not 52 here. So this here is different. Yeah, this here is different. That's a different question. So I'm going to do number 1 here, which is the simplified radical form. So number 1 gives me, I have a square root of 52 here. And how am I going to, again, divide out some factors here? Well, I can look at this number here. I'm using the prime factors and breaking down into small blocks, right? So the prime factors, I know it's an even number, so I can divide this by 2 here, right? And then 52 divided by 2 is, I believe, 26. And again, I can do the exact same thing, right? 26 is also an even number, right? So I can divide out, get another root 2 here. And we get 26 divided by 2 here is 13. Now, I know that 13 here, I can't break this down into a smaller block because 13 here is indeed a prime number. But I can actually, what I can do is I can simplify these two guys here. Root 2 times root 2 here gives me root 4 times root 13. I know root 4 here is simply just 2, right? So 2 root 13 here is my answer, right? Again, an integer and a radical here is my solution here. So therefore, 2 root 13 is the simplified radical form of root 52 here. So this here is my solution. So this here is my solution for simplified radical form. And as you can see, we can also do a long division, right? So number 2 here is they did here is a long division, right? So as let me break this down for you again. So again, I start with 52, right? I start with 52, and again, I'm thinking of a squared number here to get closest to 52. In this case, 7 squared is 49, right? So this is the closest number I'm going to get to 42. So again, so I wrote 7 in both the divisor and the dividend. 7 times 7 here gives me 49. 52 minus 49 is 3. And then I simply just double our divisor here, or double our quotient to get our new divisor here, which is 14. I'm going to add 2 zeros here to make it 300. And then I'm going to think about, okay, 1, 4, and then one value, right? Which value of 140, 140 something would be closest to 300 here? So we'd say 141 times 1 would give me 141, obviously. 142 times 2 would give me 284, right? And this one here would be my, would be closest to 300, right? So I put a 2 here and a 2 here, which would give me 284. Subtract that by 300 and you get 16. I double the quotient again to get me 144. And then I'm simply working with 144 now, right? I have 144 and I add 2 zeros here to 1600. Well, I can only have, and then do the long division step again. In this case, 1 is my only correct answer here, just because I can't fit any more 1400s and 40 somethings into 1600. So 1 here and 1 here would give me 1441. Subtract that, I get 159. And here is when I stop, because I have 2 decimal places. So therefore, this here is my answer. It's 7.21, or plus or minus 721 is the correct answer. So therefore, 2 root 13, if you plug this into your calculator, is also equivalent to plus or minus 7.21 here. And this could be 7 plus or minus as well. So the solution here is correct. And they did the long division well as well. Correct. Good analysis. And I'm just gonna put my work for the simplified radical form, because again, I'm not sure what number what kind of a question they're trying to ask me when we're looking at simplified radical form. So this would equal square root 2 times square root 2 times square root of 13. Therefore, you have square root 4 13, which equals 2 times square root 13. Therefore, simplified radical form of square root of 52 equals 2 square root 13. So solution here is correct. Number 7. So this here's number 8, I believe. And again, I don't have a problem here, but I think that what the question is trying to ask based off the solution here is, what is the square root of 256? Square root of 256. And again, we can either use the long division as given here, or we can use a simplified radical form. In this case, I'm going to use a simplified radical form. So 256 here. And again, what I can do is I can take the prime factors out, right? So the first prime factor I would take out here would be, I would probably take out a 2 here. Yes. 2. So this would be square root of 2 multiplied by, and then I would get whatever, 256 divided by 2 here. In this case, 256 divided by 2 is 128. I can do this again. 128 divided by 2 would be 64. And basically, I can stop here, right? Because I know that the square root of 64 here is indeed a perfect square. And this guy here is, I know that 8 squared here is 64. So therefore, the square root of 64 would equal simply just 8, right? So therefore, I'm going to have root 2 times 8 here. I can simplify the root 2's to root 2 times root 2 is root 4 times 8. And I know that square root of 4 here is simply just 2, right? So 2 times 8 here, which equals 16. And this here is my answer for this problem here. So the square root of 256 would equal 16. And as you can see, this solution is correct, right? They have 16 here as well. Again, they did the long division method, so they took out 256. They took out the 2, they took out the 2, and basically they took it all the way down to 1. So a much longer solution, but you can evade this if you know that the 8 squared here equals 64. So this here saves you a lot of work. Because 8 here, you could have rewritten this as 2 squared, right? This guy here, as a side note, 2 here equals 2 cubed, right? So you can say that you had 2 cubed times 1 times 2 times 2 to the power of 1 here, times 2 to the power of 1, which is then 8 times 2 here, which equals 16. So this would give you the same answer as well, but just a little side note here. So the solution here is correct. Again, you can add the plus or minus if you really want to. In this case, it's technically more correct if you put the plus or minus, but I'm not sure for the scope of this course you cared about negative numbers as well. So the solution here is correct. Good analysis. Number 9. 3 more questions here. So what are 3 equivalent factors of 3/4? So I want 3 equivalent factors of 3/4. So you look at 3/4 here as a fraction, right? When I'm talking about equivalent factors here, I'm talking about the opposite of expanding, the opposite of reducing, sorry. So this is the opposite of reducing. So recall that reducing a fraction, for example, if I had 10 over 100, recall that for reducing a fraction is dividing the numerator and the denominator, right? So I'm dividing the numerator and the denominator by the same number here. So 10 divided by 10 is 1, 100 divided by 10 here is 10. And this here is the process of reducing, right? So this guy here is reducing. So if I'm doing the opposite of reducing, I am simply multiplying, right, instead of dividing here. So this here would give me our equivalent factors. So let's do it for this example here. So I have 3/4 here, and then I'm going to multiply it by some number to get me an equivalent factor, right? So in this case, a fraction here actually has infinite amount of any fractions, right? Because I can always change what number I'm multiplying by. So let me multiply by 2 first. So this here, 3 times 2 here is 6. 4 times 2 here is 8. This here, 6/8 here, is an equivalent factor to 3/4, right? So this here is our first solution. My second solution give me, I'm changing the 2 here, maybe I'll change it to 3 maybe. So this here is 3. 3 times 3 here is 9. 9 times 3 here is 12. And this here would give me a second solution. So this here's 9 over 12. And finally, I would want 3 factors, right? So let's switch it up here. So 3 over 4. And multiply this by 10. It does not matter which number you put here again. Multiplying by 10. This would equal 3 times 10 here is 30. 4 times 10 here is 40, right? This here is another equivalent factor. So the moral of the story here is that these guys, you can put them to basically any real number you want, except they have to be the same, right? So you can put like 6 or 9 or something like that, or 4 and 1 or something like that. It doesn't matter. A fraction has infinite amount of equivalent factors. So these are just 3 solutions or 3 examples of solutions that you could have in terms of the equivalent factors of 3/4. So 6 over 8, 9 over 12, and 30 over 40. Again, they had it where they had 6/8, 9, 12, and they changed here this to 4 here. So 3 times 4 is 12. 4 times 4 is 16. So 12 over 16 is also an equivalent factor. So the solution here is also correct. Good analysis. This here's 9. So we have 2 more questions. Number 10 here is asking us 7/12 as a percent. Okay. 7/12 as a percent. So again, there's 2 ways to think about this problem here. We have 7/12 here is a fraction, right? This guy here is a fraction. And I want a percentage, right? But again, if I want a percentage here, think of a percentage here. This has to be, our denominator is going to have to be 100, right? So and again, if you look at the denominator here, we have 12. So it's actually very hard to make, there's no direct relationship between 12 and 100 here. So what I would do to this fraction is I would actually change this to a decimal first. So I would go from fraction to decimal first, and then from decimal to percentage here. So let me do this first for you. So again, if I wanted to change a fraction to a decimal, I'm simply doing this concept of long division, right? So I put 12 here as the denominator here as my divisor, and then put 7 here as my dividend, right? Again, the decimal place is always here, and I would have a 0 here. So let's do some long division. 7 times what number would be closest to 70? It would be 5, I believe. 5 would give me 60, right? 5 times 12 here is 60. This here, 70 minus 60 here is 10. Bring down the 0. My next one should be 8 here. 12 times 8 here is 96. 100 minus 96 here is 4. Bring down the 0 again. 12 times 3 is the closest guy here, which is 36. 40 minus 36 here is 4. I bring down the 0. And then basically, if I kept adding zeros here, I would have to keep adding 3s here, right? Because again, 36 minus 3 give me 4. Bring down the 0. I would have to keep that basically repeats. So I can say that this here is 3 here repeats, right? So this 583 here repeats as my decimal. So in this case here, my decimal here is 0.583. So this here is 0.583 bar. And what I can do to this is I can finally change this into a percentage, right? So if I had a percentage, again, 0.583, if I want to change to a percentage, I'm simply just multiplying by 100%, right? So if I multiply this by 100%, this would give me, again, I'm moving the decimal place 1 and then 2. So I have 58.3 bar percent, or you can round this to 58.3% here. And this here is my percentage for this problem here. 58.3% is my correct solution. As you can see, the solution here is correct, right? 58.33, I just wrote 58.3% here is the correct solution. So solution is correct. Good analysis. Let's see what they did here. They changed the 7 to 1/12, and they knew that the 12th part of 1 is 0.83333. So again, this here is the combination of the memorization method plus the long division method here. So solution is correct. Good analysis if you know common fractions as decimals. If not, then long division is required to solve for the decimal before we change it to a percentage. The solution here is correct. And finally, my last question here is number 11. Yeah, a lot of radical questions today, because I feel like a lot of students struggle with this topic of radicals here. But number 11, again, what is the square root of 89? This here will be our last problem of the day here. Square root of 89. So again, two solutions. I can have two types of solutions: simplified radical form or long division. As you can see, I think it's probably the same person who's doing this, but they did the long division, so therefore I do the simplified radical form. So I'm taking the square root of 89 here, and I'm looking at the factors here. So what can I factor here? 89 here. This one's a tricky number because is 89 here a prime number? If it is a prime number, and I think indeed it's a prime number here, so I don't think I can actually use simplified radical form here. So this is when this method fails. It was when I have a prime number. So this here is actually already the simplified radical form here. So this here is a prime number. So therefore, there's no simplified radical form here. So therefore, it's still root 89. So we have to turn to long division here. And this is when we do our long division. So we have, again, 89 here. And you can I can walk you through the solution actually for this problem as well. But if I have 89 here, I'm taking what number squared here would give me closest to 89? Well, 9 squared would give me closest to 89, right? So 9 squared here is, I know, is 81. 89 minus 1, or 81 here is 8. And then I'm putting a decimal place here because I'm going to add 2 zeros here. And then what I can do next is I am doubling my my quotient here to make it 18. So I have 1 8 here, and then I'm leaving this value blank. So I'm thinking of what number here and what number here, and they have to be the same number as always, would give me closest to 800. Well, I can basically do my calculator 181 times 1, 182 times 2. So let me do 181 times 1 is obviously 181, so that's not correct. 182 times 2 will give me 364, so we're getting closer. 183 times 3 would give me 549, and then 184 times 4 would give me the closest number, which is 736. So this here is 4, so that would be 4 as well. So I would get 736 here. I subtract both numbers here, I would get 64, and adding 2 zeros again to this value here. And then what I have to do to this guy here is I have 180. I would have to double my divisor here, so or quotient here. So 4 double that is simply 8, right? 4 times 2 here is 8, and then I'm simply leaving this value blank, right? So I have 188 blank times what number, which is also blank, equals 6400. So I have 1881 times 1 here is 1881, obviously not close. So I have 1882 times 2, which is 3764, so getting closer. 1883 times 3 here would be 5649. And let me try one more. 1884 times 4 here is 7536. So that's too big. So therefore, I would do 1883 here times 3. So 1883, and this here would be a 3, would be 5649. I can subtract both of those numbers to get me 751 here. And this here, and I stop here, right? This here is my answer. And as you can see, 9.43 is my answer here. So this is the long division using to find a radical. So therefore, I can write root of 89 is approximately equal to plus or minus 9.43. And this here is my solution for this problem here. And as you can see, they had also the correct solution here. So solution here is correct. Correct. Good analysis. So thank you so much for watching. Again, I finished my 11th problem for today. If you liked what I did today, again, you can feel free to like and subscribe to the YouTube channel at youtube.com/OneClass. Again, my name is Joey. I'm currently a teacher here at OneClass, and I'll be kind of streaming from Monday to Friday for both subjects. So again, I stream math on Monday, Wednesdays, and Fridays. And I stream chemistry on Tuesdays and Thursdays, so you can feel free to check me out. I'm going to stream again at about noon Eastern time, so about an hour from then. I'm going to focus mostly problems in the grade 10, 11, and 12 subjects. So again, if you're tuning in from the US, this would be probably the end of Algebra 1, Algebra 2, and pre-calculus questions. So I'm going to do problems with pertaining to those subjects. Yeah, and that's about it. If you have any questions, feel free to you can always ping me in the chat if you're watching, or you can just kind of submit your questions to OneClass, and I'll try to filter those out as well. So again, thank you so much for watching. Stay safe, stay healthy, have a great day. Take care.